Hi everybody, let's talk about your metric prefixes. So we've just seen some of the SI units, and SI units are good, but they're not always necessarily the best units to use for every single situation. In fact, we might need to scale them up or scale them down, and that's where our friend the metric system comes into play. And the metric system is really, really useful for a couple of reasons. Number one, if you look down at this column, you'll notice that it's pretty much all based on 10. So powers of 10, we've talked about scientific notation. We can increase the power of 10 by raising its exponent. And also, it allows us to simply insert a prefix. So a metric prefix is used in order to express different amounts. So for instance, this table is set up in the units of meters. A meter is a very set length, right? It's this defined length. We can look at the meter stick that's in the front of the room whenever we're in the class together, but there's this set length that is equal to a meter, close to a yard if you're familiar with a yard, but a little bit different. And so we have this defined distance called a meter. Instead of having different names like feet and inch and mile and things like that, what the metric system allows us to do is to apply a prefix and still be talking about meters, but basically tell ourselves, are we talking about 1/10 of a meter? Are we talking about 1/100th of a meter? Are we talking about 1/1000th of a meter? Or maybe we're talking about 10 meters or 100 meters or 1,000 meters, right? So instead of asking you to go out and run 3,000 meters, I might say, hey, go run 3 kilometers, right? And the other cool thing about the metric system is because we're using these prefixes, you can apply those prefixes to any unit. So you can apply them to grams instead of having new words like pounds, right? What's the relationship between a pound and an inch and things like that? Who knows? But if you have a kilogram and a kilometer, a kilogram is 1,000 grams. A kilometer is 1,000 meters. A kiloperson is murder. So let's not do that. But regardless, you can apply these prefixes to any of our units and they all work well. Right? So if you'll notice the way this table is set up, and this is a table that you'll have with you. This is one of the resources that you'll have. You don't need to commit this to memory. You'll notice that in the middle, we have our base unit. And everything above, we have more than one base unit, right? So we're talking about a decameter is 10 meters. A hectometer is 100 meters. A kilometer is 1,000 meters. As we go down from that midpoint, down here we have less than a meter. So a decimeter is 1/10 of a meter. A centimeter is 1/100th of a meter. A millimeter is 1/1000th of a meter. But you'll notice there are two ways to write that, right? So if we zoom in right here, we could say that 10 decimeters is 1 meter. Or we could say that 1 decimeter is 0.1 or 1/10 of a meter. And similarly, 1 centimeter is 0.01 meters. And 1 millimeter is 0.001 meters, right? 1/1000th. You'll find me in class more often than not using the whole numbers. I think these are more logical. If you want to use decimals, you're more than welcome to do that, but we've left them off here for the ease of confusion. And just so you're aware, we could do, even though we won't do it often, we could do the same thing above, right? So we could say that 1 decameter is 10 meters. We could also say that 1 meter is 0.1 decameters. Let me slide this over. 0.1 decameters. We could say that 0.01 hectometers is a meter. We could say that 0.001, 1/1000th of a kilometer is a meter. Right? Those all work. But the convention is to use whole numbers just because they're a bit more logical to follow through with. Let's see if we can try this and do a little practice problems. I'll let you pause the video and try on your own if you'd like. By the way, if you'd like to use scientific notation, you certainly may. If you'd like to write out the numbers, you certainly may. So number one, let's do a variety of different ways. You don't have to show all of these ways, but I just want to show you that there are many different ways to write this. So we could write that there are 1,000 grams in 1 kilogram. That's probably the most straightforward way that I would think to do it. We could say, if you so desire, that 0.001 kilograms is 1 gram. Right? 1/1000th of a kilogram is a gram. Or we could do either of those in scientific notation, right? So we could also say that 1 kilogram is 10 to the third grams, 1,000 grams, or 10 to the minus third kilograms, 1/1000th of a kilogram, is equal to 1 gram. So any of those methods work: orange, pink, green, blue. I will likely use either blue or green depending on the size of the value, but either one of those work. So number 2, we are talking about megaseconds. And if you find mega on your table, you'll notice that 1 megasecond is equal to 1 million seconds. So you can write out a million, or you can simply write 10 to the 6th power, which is equal to a million. Let me make that a better 6. 10 to the 6th power. We're looking for picometers. Find picometers above. You'll notice pico is at the bottom of your table, and it's 1 times 10 to the 12th. So 1 meter is equal to 10 to the 12th picometers. Or, said another way, you could say that 1 times 10 to the negative 12th meters is 1 picometer. They both work. Let's talk about candelas and decacandelas. So remember, deca is right up above the meter line on your thing. So deca is right here. Deca means 10. So if you have 1 candela, 1 decacandela, you have 10 candelas. And finally, millimeters and meters. Again, you can find millimeters. It's on the bottom of your table. It turns out that there are 1,000 of these millimeters in 1 meter. So you want to get really comfortable with thinking about this table. Again, you don't need to memorize this table, but you do need to know how it behaves in order to do conversions like these, because we'll use these over and over again all year in order to convert from different units to other ones.